Good morning, students, or whenever you watch this. We only have 14 questions left. All right, let's take a look. Right triangle ABC has its right angle at C. AC equals 12 and BC equals 5. Which trigonometric ratios are correct? Okay. SOHCAHTOA. Some of the common misconceptions have been how to find the opposite and the adjacent. So thank you for those students who've worked with me and shared their thinking and tell me what they're seeing and how their brain is understanding it, because that helps us all. First, I want to draw a picture. Draw a picture. You should have paper, pencil, and just have fun. Make it your own. Doodle. It can be messy. I'm such a messy mathematician. Some of you are such beautiful mathematicians, or handsome. Anyway. Right angle. I'm going to label it. The right angle is at C. It doesn't really matter where A and B are as long as the rest of the information is correct. If you remember back in geometry transformations, so if we reflected it, then A and B would stay the same. If we rotate it, so just make sure to label the information. So A to C is 12. B to C is 5, but they don't tell us what AB is. But we have a wonderful A squared plus B squared equals C squared. The standard convention is that the big angle, capital A, is across from the little angle, the little side, the lowercase letter for the side length. So A would be 5, and then B would be, lowercase b would be 12, and then lowercase c would be 25. Okay, I'm going to stop here because this is your problem. But anyway, use the Pythagorean theorem. Please remember that the final answer is c squared, so you have to take the square root. Sometimes you'll have a perfect square root. This looks like nope, it's not. There are some standards, maybe it is 5, 12, 13. It might be. There's Pythagorean triples, and I don't have them memorized, but you can always solve. Now, SOHCAHTOA helps you set up these ratios. Okay? You need to pay attention to what the angle is. If it is H will always be C, it will always be the hypotenuse. O and A are opposite and adjacent. Adjacent means if I'm looking for an adjacent side to angle A, here's angle A. This side, it's the side that makes up the V of the angle, right? Here's angle A. So if it's one side's the hypotenuse, that's not the adjacent. The hypotenuse will always be H, okay? So then the other side is the adjacent. Then the opposite side, if this is my angle, boop, that's the opposite side. Then you just set up those ratios. So sine is opposite over hypotenuse, which is why the O is first. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA, okay? Use your notes. Check the labeling. That's the key. Check the labeling. Draw the picture. Fundamental theorem of algebra state about this equation. The fundamental theorem of algebra is the fact that every polynomial has as many complex roots as its highest power or highest exponent term. Okay? I'm going to pause and see what they say about that, though. All right, friends. So you're going to have one that talks about the leading coefficient. That's not correct. The leading coefficient is 2. You're going to have one that talks about the highest degree and that has 2 complex roots, and that's correct because that's how we define it. Remember, complex roots include real roots. They don't always have to be with the letter I. Next, it's going to give you the solutions. So for this question, you're going to indeed need to solve, and I would recommend the quadratic equation, quadratic formula, okay? We'll practice that in class. If you don't remember it, there's so many wonderful help videos The key idea is if you have a negative number underneath your square root, just pull out the negative, make it a regular square root, and make that negative an I. That's what we did as mathematicians notationally. Okay, let's keep going. Calculators. Thin, okay. Very fun. Okay, very, very fun. We're going to do this in class. Okay, so question 32. This is just for you to preview, and I'm going to take it and use it in class. Perimeter questions, it's giving you angles, it's giving you lengths, so you're probably going to need to use a couple facts about a rectangle. Rectangle actually means right angle, rectangle. The diagonal line from corner to corner, angles, all that kind of stuff. What is the form? Why do they give you an angle? If they give you an angle, then you can find a length because of arc cosine. Okay, we'll talk about it. 33. Simplify rational equations. I want to also do this. So this is a rational polynomial. You see how they are dividing each other. I would rewrite this and remember division. So now very, very simply, if I have x over y being divided by z over w, okay, so this big quantity divided by this quantity, this means division. Division, it has an equivalent relationship, multiplication by its reciprocal. They are related. So then I could change this to x over y times z, nope, the reciprocal, so we flip it, w over z, and then I can just multiply straight across and simplify. So notice there's some factoring that needs to be done. You could cancel out terms. So if you have an x minus 2, we'll put z in the top, times something up here, but it factors out to like an x minus 2, say an x plus 3. I'm just making this up. You've got to do your own factoring. You can do it. You can do it. Over a w. The z and w could also be the polynomials. This factor, x minus 2 in parentheses, is in the numerator. This factor, x minus 2 in the parentheses, is in the denominator. So when we multiply, they'll end up dividing each other and becoming 1. So we call it canceling. You can look for common factors in the numerator and common factors in the denominator. If they're exactly the same, just get rid of them. Like Fruit Ninja. Okay. We're also going to do this in class. All right, here we go. Factor the polynomial. Looks like you might want to rearrange and factor by grouping. So if the first term of one factor is provided, complete the factoring. Oh, that's cool. So yeah, I would try that. You might need to rearrange. Notice they get a 3x minus something. So go ahead and try that out. Okay, just checking for you guys. Question 35. Concert ended. Help. We have growth rate models. Okay, so x 10 minutes. Number of people decreased every 10 minutes. Okay. X represents the number of 10-minute periods. So when that happens, what you have is this idea of for every 10 over 10, it equals 1 period. So sometimes we write our exponential functions when we have a chunk, like a chunk of time or a chunk of units over that. So every 10 is 1 step up of growth. That's kind of how we think of it, per 1. So you would put this new time formula t over 10 because every 10 seconds actually represents 1 growth period, which is what we want the exponent, the variable, to represent. I don't know if that makes sense. Hopefully it does. For that question, be sure to read it. Be sure to read what they're asking, because that one is asking more about content and reading. Logarithm, rules of logarithms. So if we wrote this, remember we have our quotient rule and we have a product rule. We have our exponent or power rule. Like, where does this 2 go when we rewrite it? So be careful to do it one step at a time. You need to do the powers before you do the quotient and product. Okay, so work backwards slowly, check a look at the answers, and you got this. Let's go 37, almost done. Initial balance of a mutual fund. So be sure to read this. Remember, is it compounding? Cool. So check your notes about a growth function, the rate. A is the initial balance, parentheses, 1 plus r over n. If there's compounding, it does. I don't know if it says that. Read it again. Rate is your growth. 1 plus if it's growth, 1 minus if it's decay, raised to the power of t time. So good luck. You got that. Reach out if you have questions. More logarithms. Drag and drop the reasons for the steps in each box to correctly solve the equation. They're all log base 4. Cool. They're all log base 4. You might want to condense it. And then remember the change of, or the relationship between exponents and what they equal, what logarithms equal. I've written it before. Look it up. Log base b of a equals x means that b base of the exponent raised to the power of x equals a. So you've got this. These are just previews. Imaginary and real parts of a complex number. The whole real part is that front number a, right? This is the real part plus bi, the whole thing. And then if it's a minus bi, take that negative with it. Keep the b, keep the I, keep the b, keep the I, whatever b is. And then whatever a is the real part, okay? Okay. But yes, remember, so, right? Right. Okay, you got this. Definitions, almost done. Solve for x. However you would like to solve for x, it's up to you. You can factor, you could complete the square, you could use the quadratic equation, you could graph. Ooh, you have to put it in standard form. You have to put it in standard form. What type of exponential function? Up to you is, what does it mean? Look up again, what does this mean? And then what is the rate of change? Think about that 1 plus r. R is the rate of change. So look at this base, but read the statements. You're going to have to read. Question 42, we're almost done. You've got this, you've got this, you've got this. What are the coordinates of the point that corresponds to this angle? It's negative angle. So one of the strategies is you could add 2 pi to find its coterminal angle on the unit circle, and then look at the coordinates. Use your unit circle, but remember it's negative, so we're going backwards 3 pi over 4. That matters. Almost done. I'm going to join you guys. Okay, so this matters. You're going to have to use trig identities as well as you're using trig identities, and so you're going to use the even-odd identities and the Pythagorean identity. You're going to plug it in. It's that 1 minus the square of 3/5, right? So check those videos out. And then pay attention to what the sign is, okay? Meaning, is it positive or negative? And then here we go. Last question. Excellent. We'll talk about this one. Awesome, guys. Thanks for watching. Reach out if you have any questions. Even on the final, send me an email, join those help sessions. I am here. I want you to understand and pass and succeed. And thanks for watching.